Imagine a single chip so powerful, it makes the fastest supercomputers of today look like toys. What if I told you it's not science fiction, but reality? Google's latest quantum computing breakthrough, a chip called Willow, isn't just 10 times faster or even 1,000 times faster. It's over 10 million times more powerful than anything we've ever seen. But what does that kind of power really mean? Could it unlock mysteries we've only dreamed of? Or is it something humanity might not be ready for? Let's dive into the chip that's changing everything, from artificial intelligence to the very limits of what machines can do. Stay with us, because this is just the beginning. To understand why Google's quantum leap is so groundbreaking, let's take a step back. Classical computers, the ones we use every day, rely on bits. Bits can only be a 0 or a 1, like a light switch that's either on or off. Simple, reliable, but limited. Quantum computers, on the other hand, use qubits. These aren't just on or off, they can exist in multiple states at once, thanks to a phenomenon called superposition. Imagine a light switch that's both on and off at the same time. Quantum entanglement, another mind-bending property, allows qubits to link together in a way that the state of one directly affects another, even if they're light years apart. This interconnectedness enables quantum computers to tackle problems that would take classical computers centuries to solve. However, for all its promise, quantum computing has faced a huge obstacle: errors. Qubits are incredibly fragile, losing their quantum state with the slightest disturbance. The more qubits you add, the higher the chance of errors, making large-scale quantum systems almost impossible. Until now. This is where Google's Willow chip steps in, rewriting the rules of what's possible in quantum computing. Willow is the first quantum chip to achieve what was once thought impossible, reducing errors as the system scales. With every additional qubit, instead of instability, Willow enhances its reliability. Google's researchers achieved this through quantum error correction. Below-threshold error rates, meaning errors decrease exponentially as the system grows. Not only that, but Willow extends the lifetime of qubit arrays beyond the lifespan of individual qubits. This isn't just a technological feat, it's the most convincing prototype of a scalable, logical qubit ever built. It sets the stage for a future where quantum computers tackle problems that classical systems could never even approach. But just how far ahead is Willow? Let's talk numbers. Google's Willow chip has achieved a feat that no classical supercomputer could even dream of matching. Imagine a task that would take the world's fastest supercomputer, Frontier, an unimaginable 10 septillion years to complete. To put this into perspective, 10 septillion years is longer than the age of the universe itself. And Willow? It did it in under 5 minutes. Willow has redefined what's possible in computing, not just in speed, but in scale and efficiency. This test, known as the random circuit sampling benchmark, isn't just a numbers game. It's a grueling computation designed to push quantum systems to their limits. Willow didn't just meet expectations, it exceeded them. Google Quantum AI's founder, Hartmut Neven, suggests that Willow's capabilities might be explained by computations happening across multiple parallel universes. While this idea is speculative, rooted in multiverse theory, it offers a glimpse into just how mind-bending quantum mechanics can be. But the million-dollar question is, how do we go from benchmarks to real-world breakthroughs? That's where the story gets even more exciting. Google didn't just add more qubits, they perfected them. Willow uses a 7 by 7 qubit grid to scale without losing reliability. In fact, as more qubits are added, error rates decrease exponentially. This kind of stability changes everything. This isn't just theory. Willow's ability to reduce errors exponentially proves that quantum error correction works, even on a large scale. And that's the key to making quantum computing not just experimental, but practical. Imagine quantum systems capable of designing life-saving drugs, creating more efficient batteries, or solving equations for fusion energy. These are the problems Willow is poised to tackle. Problems classical computers have barely scratched. Now imagine two of the most transformative technologies of our time: artificial intelligence and quantum computing, not just working side by side, but amplifying each other's strengths. That's exactly the synergy we're witnessing today. AI excels at identifying patterns and making predictions, but it's bottlenecked by the immense computational power required to process vast amounts of data. Quantum computing removes that bottleneck, providing speed and efficiency on a scale we've never seen before. Take training AI models, for example. Tasks that once took weeks or even months could now be completed in hours. Quantum systems could optimize AI algorithms to solve problems previously thought impossible, like real-time climate modeling or simulating complex biological systems. Together, AI and quantum computing form a partnership that's not just about making machines smarter. It's about reshaping the way we approach science, medicine, and even everyday life. Willow is about changing the way we tackle the biggest challenges humanity faces. From energy to medicine, the ripple effects of quantum computing are set to touch every corner of our lives. Imagine curing diseases by simulating molecular interactions in seconds, or designing batteries that could power cities without ever degrading. And then there's fusion energy, a potential limitless power source that quantum computers could help bring within reach. But with great power comes responsibility. As we unlock these possibilities, questions about ethics, security, and control take center stage. Could this technology fall into the wrong hands? Could it create problems we haven't even begun to foresee? Well, quantum computing offers a future that's equal parts inspiring and uncertain. It's a leap into the unknown, and every step forward brings us closer to answers and to new questions. Willow isn't just a chip, it's a turning point. It's the key to a future that could redefine what's possible for humanity. But will we be ready for what comes next? Google has a bold roadmap, achieving useful beyond classical computation, a point where quantum systems solve real-world problems that classical computers never could. From advancing material science to unraveling climate change, this is the next frontier. Google has opened the door to researchers and developers worldwide with open-source tools, partnerships, and even a Coursera course on quantum error correction. They're building a global community to tackle this challenge together. But the road ahead isn't without its challenges. Bridging the gap between experimental quantum computing and practical, scalable solutions will take years, possibly decades. The technology is still in its infancy, and scaling it for real-world use is a monumental task. So what's next? It's not just about Google, Willow, or even quantum computing. It's about us, all of us, taking part in a future that's being built right now. As we stand on the brink of this monumental breakthrough, it's clear that Willow is more than just a chip. It's a window into a future we've only dared to imagine. It represents a turning point, where the impossible becomes possible, and the limitations we've long accepted begin to dissolve. If you're as excited about the future of AI and quantum breakthroughs as we are, don't forget to like, comment, and subscribe. Stay tuned for more updates on the latest innovations that are shaping our world. We'll be bringing you the next big leap. Don't miss it.